we have taken a look how to graph sine, cosine, transformations on sine and cosine, the basic graphs of tangent and cotangent, and now we're just going to talk about the asymptotes of the graph. So when we graphed the basic graph of tangent and cotangent, we saw that whenever it makes the denominator 0, the function will be undefined, and when the function is undefined, you will have asymptotes. Even though we're not going to discuss the graphs of secant and cosecant, they have the same situation, the situation that they will have asymptotes wherever they are undefined. So you can actually find the asymptotes of the graph. We can find where it's undefined without having to graph. So this is what we're going to do in this video. So we have 3 examples. The instructions are going to be the same at the beginning. Find the asymptotes. What's going to change is the interval you're finding the asymptotes on and the function, of course, that you're finding the asymptotes of. So as a quick reminder, algebra reminder, you have 2 types of brackets in an interval. This means that this is including the number, and this means that it's not including the number. Okay, so we have f of x equals 3 secant of 3x. So the first thing you're going to do is look at the basic function. And the basic function is just going to be whatever trig function you see inside. So the basic is y is equal to secant of x. The next thing you're going to do is you're going to think about the domain of this function. Now, secant is 1 over cosine. So it's going to have the exact same domain as tangent. The domain that cosine cannot be 0, okay? Because the bad thing is happening here. So this cannot be 0. So we get that the domain is all real numbers except odd multiples of pi over 2. And we'll draw a little visual here on the side. So remember 1, 0, 0, 1, negative 1, 0, 0, negative 1. So cosine is 0 here and here. So that's pi over 2 and 3 pi over 2 and then 5 pi over 2 and then 7 pi over 2 and so on. And that's how we created the pattern for secant and tangent, the domain. And so what we do is we write the current asymptotes. So the asymptotes are going to happen here, right? This is where the asymptotes are going to happen, in the basic one. That's important. And of course, they are vertical asymptotes. So we're going to write the basic. So the basic ones are, I'm going to leave some space because remember, there are infinite amount of them. So I'm going to write negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and then you would continue this in the odds all the way to the right, all the way to the left, okay? Now we're going to look at the function that's given to us, which is 3 secant of 3x, and we're going to look at the transformations. So the transformations that are being done on f of x is equal to 3 secant of 3x is that you have the 3 in the front, so A would be 3 and B would be 3. And there would be no C, there would be no phase shift. So what would happen is that this, the y's, would be multiplied by 3. And the x's would be multiplied by 1/3. Because remember, when you do the horizontal transformation, you take the reciprocal. So there would be a vertical stretch and a horizontal shrink. Now, because the asymptotes are vertical asymptotes, they're x equal. The only transformation that's going to affect the asymptotes is the x transformation. So we are going to horizontally shrink the asymptotes. So we have that this is going to become 1/3 x. And when we do that, we multiply everything by 1/3. So that's negative pi over 6, pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6, and so on. Now, we need to answer specifically the ones that are in the interval. So we are 0 to 2 pi. Now, our asymptotes have denominators of 6. So it's a little bit hard to compare them to 2 pi when 2 pi is the denominator of 1. So what I'm going to do is I'm going to rewrite 2 pi with a denominator of 6. So multiply the top and the bottom by 6, and we get 12 pi over 6. So we need all of our answers. We have x equals. So the first thing I notice here is that definitely negative pi over 6 is not going to be our interval because it's negative and our interval starts at 0. So we have, the first one is going to be pi over 6. then 3 pi over 6, which actually reduces to pi over 2, then 5 pi over 6, then 7 pi over 6, then 9 pi over 6, then 11 pi over 6, and the next one would be 13 pi over 6, but 13 pi over 6 is greater than 12 pi over 6. So I don't want to continue. Now, I do notice one thing I should do, which is the 9 pi over 6 reduces, they both have to 3 pi over 2. So your answers should be simplified. And here are my asymptotes. So these are the x's where 3 secant of 3x is undefined. This is what's going to make it bad. It's going to give you an error message. And at every single one of those x's, you will have a vertical asymptote in the graph from 0 to 2 pi. Okay, let's do another one. Find the asymptote. So we're going to do exactly the same thing. First, we're going to look at the basic. Y is equal to cotangent of x. Now, cotangent of x is cosine over sine. So the domain of cotangent is all real numbers. And then if we look at our little diagram that we had here, I'll do it in orange. It's going to be, sine is going to be 0 here and here. So on the x-axis. So the domain is all reals except all multiples of pi. And we've talked about before that you don't have to write the word all. It's just multiple, but just as an emphasis that it's the even and the odds. So that means that the basic ones is x equals. And I'll write a few, negative 2 pi, negative pi, 0 pi, 2 pi, 3 pi, and so on. And then we look at the function. So I'll write it down here. I have f of x is equal to negative 2 cotangent of 4x. A is negative 2. B is 4. So I would multiply my y's by negative 2y. And I will multiply my x's by 1/4 x. So that would be a vertical stretch and reflection and a horizontal shrink. But, like we discussed before, only the vertical is affecting because it's a vertical asymptote. So what I'm going to do is multiply my x's by 1/4. And that's going to give me negative 2 pi over 4, which is negative pi over 2. Negative pi over 4, 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4. So we have, before actually I'm going to do this real quick so that you see the pattern. Let me keep it as 2 pi over 4. Okay, so already I can tell that these are going to be out because my interval is 0 to pi, including 0, not including pi. So the next one in my list would be 4 pi over 4. And then the next one would be 5 pi over 4. And then the next one would be 6 pi over 4. But 4 pi over 4 is equal to pi. And pi, if you look at the interval, it has an open bracket. So you can't include that as part of your answer. So my only solutions, my only vertical asymptotes in my interval, don't forget to write them as x equal 0, pi over 4. Now I'm going to reduce it to pi over 2 and 3 pi over 4. And there they are. Let's do one more for good measure. Find the asymptotes from 0 to 4 pi now. F of x equals tangent of 1/2 x. Okay, our basic is y is equal to tangent of x. Tangent is sine over cosine, so it will have the exact same domain as secant. So the domain is all reals except odd multiples of pi over 2. We have x equals, and from here I'm just going to start at, I can see that it's going to start at 0, so I'm going to start at 0. But 0 is not. I'm going to start at the positive, so pi over 2. 0 is not an asymptote of tangent, only of cotangent. And then 5 pi over 2. And then 7 pi over 2. Okay, I'm going to create, that helps me create a little pattern. And then I take a look at my function, y is equal to tangent of 1/2 x. So b is 1/2, which means that I will take my x's and multiply them by 2. So this will become 2x. And the asymptotes become, so I should do a little arrow here actually, pi, 3 pi, 5 pi, 7 pi. And already I can stop, I can see which ones. I can only go to 4 pi, so this is out and this is out. So my final answer is x, and I only have two of them, pi and 3 pi. And that's it in my interval. So those are my two vertical asymptotes of tangent of 1/2 x.